Hello all, this video is on NEXTION human machine interface display with Arduino. This is a programmable display. Basic and enhanced models are available of different sizes 2.8, 3.2 and 3.5 inch sizes. In this video we will be using basic models and 3.2 inch display. 4024 means 400 by 240 resolution and 3.2 inch size. 3224 means 320 by 240 resolution of 2.8 inch size. There is also 4832 480 by 320 of 3.5 inch size. In this video we will be using 3.2 inch size. This display has an interface board on the back side with the SD card slot. This SD card slot can be used to upload TFT file. There is 32-bit processor STM32F030 for interface. A connector is provided. It is serial connected to connect with Arduino. This simple connection 5V ground TX and RX. Just through serial port you can upload code from Arduino to this display. For uploading code you can use USB to TTL CP2102 device or SD card in the SD card slot. Either method you can upload TFT code developed using NEXTION editor. We will see both these methods in this video. There is also clone available in the market which is printed TJC. These TJC models are not original and it requires USART HMI IDE to develop code. Code developed using NEXTION editor cannot be uploaded onto TJC. So always use original NEXTION displays and not TJC. This is TJC is a Chinese clone. Now visit the NEXTION website and download the NEXTION editor. Download the latest editor and then download the library zip file. Always download the ITED library and do not install using boards manager of Arduino IDE. That library is different. So these are the essential files before getting started. NEXTION editor, NEXTION library, ITED library, and then some background images. To convert the background images to fix the resolution, to match the resolution, we use INKSCAPE image editor and then Notepad++ editor to edit the configuration file. To start with, unzip the downloaded library folder and then copy it. Browse to the location program files, Arduino, and then paste it under libraries. Now rename this file to NEXTION. Delete the wordings ITED and rename it just to NEXTION. Now open this folder, NEXTION library folder, and look out for config file. Actually this library is designed for Arduino Mega. To use with Arduino Uno, you have to edit this next config file. Open with the Notepad++ editor so that you see the line numbers. You comment out the lines 27 and 32 and then edit the line 37. That is you change the serial 2 to serial. Serial 2 is for Arduino Mega, so just change it to serial and then save the file. You need to open the Notepad++ editor as administrator and then save this file. Now let us change the downloaded image to the resolution that matches the NEXTION display. We are using 3.2 inch display, so resolution is 400 by 240 height. You can download the images from Pixabay website. Visit the website and browse the huge collection of copyright free images. There is also paid versions also. You can select the copyright free and then download the wanted images. There is also horizontal as well as vertical type of images. We have downloaded one image here, and using INKSCAPE image editor we'll change the resolution to match the NEXTION display. Open the INKSCAPE editor and then file document properties. Change units to pixel px and then modify the width to 400 and height to 240. 400 by 240. A canvas is created now. Now file, import and select the downloaded image. This is of high resolution. You just click down OK to download the image into the INKSCAPE image editor. Now you will see some handles around the image. Pull the handle to match the canvas of 400 to 240. You can just pull all the sides so that it matches 400 by 240 canvas. Now drag the image inside the canvas. You can further drag also so that it matches the edges. Now select view zoom selection so that you can see zoomed picture. Now you can do the final dragging and so that it matches the edges. Drag the handle so that it matches exactly the canvas, 400 by 240 canvas. Now save the file. Select the file name, provide a file name and select it as PNG file. So it is of type Cairo PNG. Select it and then save the file. Now exit the INKSCAPE editor. And then proceed with the NEXTION editor installation. Once the NEXTION editor is installed, open the NEXTION editor. This is the NEXTION editor, HMI editor. The main menu is on the top. On the left hand side you can see the toolbox with a variety of components. You can drag and drop any of the components onto the canvas. There is also the picture font area, page area, attribute area, and then compiler output and event window. Now click on File, New, and then create a folder, new folder for the project, and inside the folder provide a file name for the HMI file to be created. Let us give the name as LED on off and then click on save. The file will be saved as HMI file, .hmi file. Now a new window will open where you have to select the display type. Our display is of type 3.2 inch. Resolution is 400 by 240. You have to select the correct model. Now you can select the horizontal direction. Display direction also you have to select. We select the horizontal direction. A new canvas is created with 400 width and 240 pixel height. This is the page area where you see only page 0. This is the attribute area to the bottom of the page where you see the attributes of the components you drag and drop on the canvas. Now you have to create the font. Under tools, click on font generator. You can select the size of the font to be used and the type of font. provide a file name for this font file, like my font, and then save the file. The file will be saved as ZI file. You save all the files in the same project folder so that it will be easy to access for future. Now click on add this font file to the project. At the left hand side bottom, you can see the font file is added to the project. Now click the picture tab and then click on the plus symbol. Browse to the location where we generated the new resolution file using INKSCAPE. This is the 400 by 240 resolution file we created using INKSCAPE. Select that image and then click on OK. The image file will be imported into the image picture folder, picture area. Now click on picture on the tools section. The picture attribute will be shown on the right hand side. The ID is 1, object name is P0. So you have to note down all this ID and object name which will be used inside the Arduino code. Now double click on PAC area and then select the picture. Now the picture with size resolution 400 by 240 is seen inside the canvas. You can click on debug to see any errors are created. If resolution is not correct, you will see some errors. Now drag on 2 buttons inside the canvas over the picture and then a text component. 3 components we are using, 2 buttons and 1 text. Now click on first button. Under the attribute area, you see the ID as 2, object name as B0, and you can change the text to LED on. Just double click on TXT and then change the name to LED on. Same way, click on the button 2. Go to the attribute area, see the note down the ID is 3. It is in the same page 0. Object name is B1 and text you just change it to LED off. Same way, click on the text component and change the name to status. Note down the ID and object name of this status, which will be used in Arduino code. You can drag the size of the text bar by pulling the handle. At the bottom you see 2 events, that is touch press event and touch release event, that should be programmed for the buttons. Now click on LED on button and then you select the touch release event so that we program for when the button is released. You have to put a tick mark against send components ID. You do this for both the button, LED on button as well as LED off button. Now click on debug button to see the result. 3 elements are displayed: LED on, LED off and status. When you press and release LED on, a hex code is sent to the serial output. When you press and release LED off, another hex code is sent, which is used in the Arduino code. This hex code starts with 65 and ends with 3FF, which represents end of message. 65 means touch detection. 00 is page ID, which is page 0 here. 02 is component ID. LED on means 02. LED off button is 03. And final 00 is button release event. Now click on compile to generate the .tft file. The .tft file is generated. To see the file, you open file, open build folder, and inside the Biani folder you see the .tft file. You have to manually copy this file and paste it inside your project folder. The .tft file is the file you have to upload onto the NEXTION display. There are two methods to upload this TFT file onto the NEXTION display. Before clicking upload, we'll see the first method. First method is by using USB to TTL device. Here I am using USB to TTL built on CP2102. The connection between NEXTION display and USB to TTL is simple: 5 volt to 5 volt, ground to ground, TX to TX, and RX to RX. RX to TX. Reverse. No separate power source is required. You connect the USB to TTL to PC. Now you can see the welcome to use NEXTION editor on display, and now click on upload. Port will be auto detected. Baud rate, you have to select the maximum 115200. As this method, USB to TTL method, is bit slower, you have to select the maximum speed and then click on upload. You can see the LED blinking on the USB to TTL according to the upload, and the data the TFT file is being uploaded at the baud rate of 115200. It will take some time, and the final display you can see on the NEXTION display. Now let us see the second method by using the SD card. You need a memory card reader. You place the SD card onto memory card reader, plug in onto your PC, and then right click on the USB SD card and then format it. Ensure that you are formatting the SD card only. Select the FAT32 file system and then format it. Once the format is finished, you copy the .tft file that is generated using compile and then paste it inside this SD card folder. There should be no other files inside this SD card. Only the .tft file should be there. Now remove the SD card and then plug it onto the NEXTION display. Only the power wires are required. The TX RX wires are not required now. Only the 5 volt and ground. Now plug in the USB to TTL to PC. You can see the file uploaded very fastly compared to the USB to TTL method. The SD card method is faster. Now you can remove the power and then the SD card. You can remove the SD card also. Now provide the power back. You can see the display you created now. Now let us see the code for the Arduino code used in this project. To start with, we have to include the nextion.h header file, and then each component is declared using next button function. We have 4 components in this project, out of which 3 are used in the Arduino code, that is B0, B1 and T0. Each of these components is declared using next button function. For example, B0, for B0, declaring B0, we use next button B0 equal to next button 0, 2, B0. That is 0 is the page ID, 2 is the component ID, and B0 is the name of the component. And then we create a list array using next touch only for the touchable components. We have 2 touchable components, B0 and B1. So we create an array B0, B1, and then we add null at the end. And then we write the code for the pop callback function for both the buttons, for button 0 and button 1. For button B0 component, pop callback function, inside this pop callback function, so when the LED button is released, the LED is turned on and the state is displayed as on. So the code is written accordingly. We make the pin 13, digital pin 13 as high, and then we change the status. Same way for button B1 also. When LED off button is released, we make the LED off and change the status. And then we attach the function created to corresponding events. This is done inside the void setup. When you click B0 LED on button, B0 pop callback function is called, which is called by the function attach pop. And finally, inside the loop, we just keep a watch on the list so that each event is followed repeatedly. Now let us see the connection between Arduino and the NEXTION display. It is very simple. 5 volt is connected to 5 volt of Arduino, and the ground is connected to ground. As soon as you give the power, you can see the display you have created. Now before connecting the RX and TX pins, you have to upload the code. Click on upload. Now the code is being uploaded. You can see the LED blink, upload LED blinking. Once the code is uploaded, now you connect the TX of NEXTION display to RX of Arduino and RX of display to TX of Arduino. Since we are not using any software serial, you have to do this. After uploading only, you have to connect this. Now you click touch on LED on. You can see the LED 13 on, and touch on LED off. You can see the LED off. For better visibility, let us connect an LED with the resistor to digital pin 13. Now when you touch and release LED on, the LED connected at 13 goes on. When you touch and release LED off, the LED goes off. So we have programmed only for the release event. So when you release the hand, release the finger, then the event is triggered. Thank you for watching.